NSRCEL for hosting us today. I'll keep this pretty short. I just wanted to maybe talk a little bit about the MOU that we'll be announcing today, and why I think it's going to be it's going to create a lot of value for this community and the larger EV community as well. The three areas that we are planning on collaborating is one on the policy side, which is proposing various policies to government agencies, as well as helping startups navigate policies in this very dynamic kind of framework. I think many different stakeholders are trying to figure this out and figure out something that's sustainable in terms of policies, and I think this is going to add tremendous value, I think, to the startups that we will be helping. Secondly, on the technology side, seeing how we can leverage our Discovery Studio and the facilities that we have to help a larger community of startups in this space, in the electric vehicle space. And lastly, when it comes to providing a network, and I think not just a network of companies in the clean mobility space, but also larger network of companies that could help in other auxiliary roles, perhaps even connects with regards to funding as well. I think what we're doing is really we're widening the scope a little bit when we've been very focused on let's say we've been very focused on cultivating this electric vehicle community. I think introducing a larger ecosystem is also going to be very important going forward. With that, thanks again for joining today. Back to you.
Thanks, Wes. I think we can maybe stay here, or we'll invite you back again for MOU. Yeah. Okay. Now I will request Anand sir to please come and share words and introduce NSRCEL, how things are exciting in EV space. Over to you.
Thanks so much.
Just sir, it's very embarrassing. Good afternoon. Thank you so much for being here. Welcome to IIM Bangalore. Welcome to NSRCEL. My team asked me to give a half-an-hour speech. I don't think I know so many words, so I'll probably take a couple of minutes. A quick introduction to NSRCEL, the NS Raghavan Center for Entrepreneurial Learning. We are IIM Bangalore's incubation center and startup hub. One of our major focus areas is to encourage entrepreneurial energy in areas where the broader ecosystem in India is still very nascent. But we believe that the downstream economic or societal impact could be very large if you stay the course. And one such area for us is the area of sustainability, within which clean mobility is such a large part. And as we have learnt about that space, we also realize that to create the right kind of entrepreneurial energy within the ecosystem, you have to bring in a few things together. Shreyas talked about influencing government and policy. He talked about the right industry networks and corporate connects. I'd also want to include things like our fundamental R&D. There's a lot of fundamental innovation in engineering and design that impacts the space. There is a lot of conversation around protocols, interoperability that impacts the space. About 2-3 weeks ago, we had the battery swap draft policy which was put out, and it's already attracted a lot of attention, a lot of thoughts from industry opinion makers on their perspective on what that might mean. And that's one example of many things that need to come together. From an NSRCEL perspective, as we look at entrepreneurship in this space, we also realize our ability and opportunity to convene that ecosystem is very powerful. And as we roll out our incubation programs in the space, we will try very hard to bring in this ecosystem. The objective of the ecosystem, of course, is bringing in knowledge to entrepreneurs such as you, and therefore guide your own product market approaches. It also opens up very valuable use cases for the government corporates and the industry to look at and therefore accelerate. For us, it gives a great opportunity, as I said earlier, to participate in a space that, if we stay the course, could have huge economic and societal impact downstream. So that's our perspective of NSRCEL, and if some of you choose to want to have a safe incubation space through the journey in your clean mobility EV spaces, do speak to some of my colleagues who are here, speak to me later through the day. We'll be happy to share our thoughts. Very thrilled on this partnership with Micelio, Shreyas. There's a lot to learn from you and your organization. The sheer commitment that you demonstrated to the space, not just from a funding ecosystem and bringing your technology infrastructure, but this entire network. This morning and afternoon, I was speaking to some of the ventures who are sitting in NSRCEL. Many of you are flown in from different cities within the country, which for me itself was an eye-opener. You've taken all the effort to spend a couple hours with your peers in the industry in Bangalore, which means there's so much of energy, so much of passion that is within your network. And it's a great opportunity for NSRCEL to participate here. Thrilled to be part of this partnership and see if we can make history happen. Once again, welcome to all of you. Looking forward to engaging with you through the course of the evening today.
Thanks, Anand. I will request both Anand and Shreyas to please proceed for the MOU signing ceremony.
So much, sir. We should do this.
Yeah.
Thank you, sir. Thank you.
Thank you. Thanks, Shreyas and Anand. It's great that both of our entities are now working together. Happy to have support from NSRCEL team for this event. So now we will proceed to the next section of our today's session, which is basically a panel discussion on basic emerging battery technologies, swapping infrastructure. And I am very happy to introduce our panel today, which is with us. We will start with a quick introduction. I will request all our panelists to go one by one, talk about the company themselves, their interests, and then we will then proceed to the theme and the question set which we have collected from the community. And we would like our panel to share their views, and we will definitely then later on ask for questions if our community here would like to ask the direction. So we will start with Naveen first.
Myself, Naveen Kumar, Head of Engineering at Nexcharge. Nexcharge is a brand. It's a joint venture between Nexide and Nexcharge. So here we make lithium-ion battery pack for two-wheeler application, three-wheeler application, and also the commercial vehicle application. So we make battery pack from low voltage to high voltage system up to 600 volts. Our factory is recently commenced, and we are catering many of the OEMs for their need. Thank you.
Thanks, Naveen. Now I will request Pratik from Neuron Energy to make a quick introduction. Over to you.
Hi, I'm Pratik here. I'm the co-founder of Neuron Energy. We make lithium-ion battery packs for electric two-wheelers and electric three-wheelers. We are an EV-focused company providing all sorts of solutions only for EV business. In terms of batteries also, we only focus on EV batteries. We started our journey with lead acid back in 2017-18 and slowly I moved to lithium-ion. Moving forward, we are open to exploring other technologies as well, but our core focus will be EVs and what all we can provide to the EV ecosystem.
Thanks, Pratik. Now I will request Ganesh from Renon Energy to proceed with the introduction.
Hi everyone, this is Ganesh. I represent Renon. We are a lithium-ion battery pack manufacturer. We have around 250 megawatt hour installed capacity for building lithium-ion battery packs. We predominantly work on NC and LFP chemistries today. We are working what we see lithium-ion battery pack is almost like a 360-degree development, and we believe our core business is on the battery packs, and we work on the technology, full technology stack, starting from DMS telematics to the pack manufacturing development and the analytics that goes around it. Right? I'm happy to be part of the panelists, and thanks for this opportunity as well. Thanks.
Thanks, Ganesh. We have next Vineet with us. He's founder of Urja Energy. I will request Vineet to proceed next.
Thanks a lot. Thanks, Hiten, first of all, for the opportunity. Hi, everyone. I'm Vineet Dravid, and I'm the co-founder of Urja Energy. Our goal is to simplify design. We want to make a software, a predictive modeling software, which you can use for thermal management of batteries and capacity fade, degradation of batteries at the design phase, so that all of you design and make better batteries. But more about that later, so glad to be here.
Thank you. Next, I will request Hiren to go next.
Yeah, hi. Good afternoon, everyone. Thank you, Etienne, for the invitation, and my co-panelists, thank you for sharing the dais. My name is Hiren Shah. I am the founder and CEO of Replus Engitech Private Limited. We are battery pack manufacturers based out of Pune. Our strategy has been a bit, you can say, reverse in a way, because we started with high voltage ESS solutions, and now we are going into EV. So I'm happy and proud to share that our team has completed 20 megawatt hour of BESS project, which is at Sun Temple, Modera, which we did with Mahindra Sustain. And in India today, this is the largest ESS project as of today, standing, which is powering the entire village of Modera by sun energy. So during the daytime, the sun is being harnessed, and the energy gets stored in the battery, and the battery will take care of the load from evening 6 o'clock until morning 7 o'clock. So we started with that, and then now we are entering into the EV space. I'm happy to be here and happy to share my knowledge and wisdom with all the members. Thank you.
Okay, so once again, thanks for all the panelists to introduce themselves. We will now proceed to the panel discussion. As I said, the theme is e-batteries and battery swapping technologies, and I have a couple of questions to all of you here, which will help our community. And there are various kinds of companies in the community, from battery pack development to component development to even vehicle development entities which are here, and some good names, some startups. It's a good mix of companies, including larger corporates, startups, which we have here. And there are some problem statements which are some interest areas which is common to all of us. So today we would like to share some light on these topics and see how our learned delegates here can share their views, that others are also inspired and aligned, and how we as a community we can proceed to resolve those issues and those concerns, and as a collective force we are at a better position than we are at currently. So my first question is basically, what are the upcoming trends in EV battery technology considering next 5 years? Now you all are in battery space. Obviously you are working on various projects which are of strategic importance to not only your company but to the industry as a whole. So we will start with this question first. I will start with Naveen and then let others also share their views. So Naveen, once again, what is your view on what are the upcoming technology trends as far as the battery technology is concerned from your point of view for next 5 years? The audio.
So I was going through the literature and the research, the trend direction, and also our cell manufacturing roadmap. So currently, if you see the LFP chemistry, we are at 185 watt-hour per kg. So I see that with the pre-lithiation and anode silicon at anode side, I think we can reach up to 220 watt-hour per kg at 2020. I was saying that LFP currently at 185 watt-hour per kg. So because currently we are addressing at anode side, if you have instead of graphite, if you have silicon oxide with pre-lithiation, so the gravimetric energy density can be increased up to 220 watt-hour per kg. that brings little closer to the NMC chemistry which currently are there. And if you apply same kind of principle with NMC, with 8111, and if you use same the silicon oxide plus lithiation, so I think we can come closer to around 280 watt-hour per kg. So that is something we can visualize at 2025. And since Nexcharge has partnered with SVolt, we also see the roadmap in that direction. So that is feasible. So, and other chemistry is something which Reliance recently suggested is that sodium ion. So that has energy density around 140. I think this is something we can, is low cost, and we can use it in for the stationary application. There is one more contender is lithium sulfur. Okay, still it is research is going on. That we can reach around 372. That is what the research says. In terms of form factor, in 21700, right? People wants to go towards 46800, like Tesla has done with tabless one. In addition to that, everyone is in love towards blade cells, right? So because the blade cell offer that effective thermal management, because we have the terminal on either side and it's better for thermal management. And also like we can reduce because the approach is we can directly go from cell to pack or cell to chassis. In that way, we can achieve the, in terms of gravimetric, maybe another 15 to 20% increase. And volumetric wise, we can go another 50% high. So, and we can also reduce the height of the battery pack, which gives at the vehicle level larger leg room. So, and also it can be comparable with respect to NMC, right? So NMC is little more, we are worried about safety, but LFP can offer same kind of energy density and with safer option. So there are a lot of things going on in solid state batteries. That is one area where that a lot of research is going there to make the battery packs which are safer. And also we can have a very high energy density up to 400 to 500, which is a wish. The researchers are going towards that. In addition to that, around the battery, I think there are a lot of improvements in the smart BMS and a lot of prognostic and diagnostic approaches to make sure that batteries are safe. So I think these are something I'm trying to capture in once.
Sure. Thanks, Naveen. Surely quite detailed insights on various new age technologies which companies like Excite and Nexcharge are working. I'm glad that he can share those roadmaps and those directions with us. Next, I will request Prateek to share his views. In terms of the same question, what are the EV next 5 years? How do you think that battery technology is going to evolve?
So I'll break the answer into two parts. I believe that immediately the trends that we are looking at in terms of battery technology, one is the impetus and tremendous focus on thermal management. So we are talking about liquid cooled battery packs for three-wheelers, and different applications in thermal management should come about within the next 1 year. Over and above that, immediately there is a great need to improve the BMS. So the shift in the market from basic use of basic BMS or MOSFET-based BMS to a microprocessor or a contactor-based BMS is what we are looking at. Even from market point of view, from customers, they are willing to experiment, or they are willing to pay more now for more safe BMS and to avoid certain incidents that have happened in the past. In terms of long term, we expect multiple changes to happen. There will be alternative technologies to lithium that might come in. Those technologies might have certain applications itself. It might not be, it might be something else. But certain battery technologies will come in. It would be too early to comment upon what technology will commercialize and who will adopt that technology right now. But that is what we are looking at in terms of 5 years. We also might see some fast charging cells coming into the market 4-5 years down the line as technology evolves, which will change things very rapidly as the cells and the battery pack can be charged very fast compared to what it is now.
Thanks, Pratik. And now I will request maybe we need to go next and share it with you.
Can you hear me? Yes. Awesome. All right. So thanks. I come, I'll give you a slightly different perspective because I don't come from a manufacturing background. I come from a research and development and a simulation background. Looking at batteries as a, from their chemistry and the physical phenomena happening in the batteries. But so first of all, I would like to say it's a very exciting space. When we talk about the upcoming trends in EVs, I think it's full of opportunities. It's very exciting. And just to put things in perspective, remember that IC engines have been around for 300 years. The first roadworthy car came out less than 20 years ago, right? So that's the kind of technology we are dealing with. And so first of all, it's very important to accept that we don't know what we don't know, right? So there are many things which are going to happen in the next 5 years, which we may not be aware of today. Now, I don't want to get caught into the technical details. Of course, there's a lot of talk around new technologies, like he was mentioning, adding silicon to the anode. That's shown to be of great promise, and it's going to be commercialized soon. And it's the percentage of lithium is going to keep increasing. Then we have talk of lithium-air batteries, solid-state batteries. Obviously, in India, sodium batteries are projected to get a big push. So there are a lot of these things. Today we may know some of them, but I'm sure there are many other things we don't know of. But the important thing is to understand that we need to accept that there are a lot of exciting opportunities coming up, and let's try to figure out how we can tackle these challenges. And the reason I'm saying that is because the second part of this is battery swapping. And I think India is going to become a very exciting place for battery swapping. So let me tell you a small sort of story. Apart from my day job, I'm also working with the DST and the Niti Aayog to come up with a predictive capability modeling group for specific to India. And this is especially needed for the PLI ACC that we have come up with, and for the battery swapping project. So when I began at the outset, I was very skeptical about the entire battery swapping initiative. And I know that there are a lot of people, even in this room, who are possibly very skeptical about battery swapping. But I must confess, from the time that I have started interacting with government officials, I'm completely sold on swapping. I'll just take a minute to explain why. Because the thing is, whatever challenges I mention to them, and others mention to them, they know all of them. I know many of you may have given your feedback by 5th June, hopefully you have. I'm sure there are challenges. Everybody knows there are challenges. But what the government is saying is we are willing to put money in. Collectively, let's figure out how we can overcome these challenges. And I think their intentions are excellent. So what they're saying is, let's come up with a small pack, a 1 kilowatt-hour pack. And they want this to be used by everybody, not just by EVs, but for any application. And they say it should be a simple pack, maybe 8 to 10 kgs, which you can, even an old lady can lift or a young boy can lift. So they want it to be a universally usable pack. And now figure out how you can use it. It's an engineering problem. Maybe you'd like to stack packs together. You'd like to use it in conjunction with a fixed battery in your EV, whatever it is. But the point is, this is one example of how battery swapping is going to be an exciting challenge for India, right? See, as a OEM, you can either choose to have swappable batteries or not. But the fact is the government is committing to put in money. So why not come together and make this an exciting technology? So I think that's why battery swapping is so exciting. And I'm sure there are many such technologies which are going to come up in the near future. The important point is I think we need to accept that we don't know what we don't know.
Thanks, Vineet. I will now request Ganesh ask the same question. What are your projections and thoughts?
I'll start with from a battery player perspective. The kind of questions that we generally get is, the first question that we generally get is, what is the cost per kilowatt hour of your battery pack? So when you speak about cost per kilowatt hour, the second question that we ask is, what is the battery pack that you want? Right? The idea is today the market is moving through an analysis called wheel-to-wheel analysis, what we call internally, where we look at the performance of the vehicle and what are the requirements of the vehicle, and then come back to sizing the battery pack. And because of this aspect, we generally end up in customizing the battery pack to a larger extent. And starting from selection of chemistries to selection of the BMS to selection of all the other components that goes into battery pack. This is done backwards, which is from a battery manufacturer or battery player perspective, this is well-to-well analysis, right? But what we generally wanted, the industry, what we also see in certain sense, the industry moving from a perspective of well-to-wheel analysis, right? Or well-to-wheel sizing, where you first work on the standardization of certain, the chemistry, the battery pack, and then go to the performance of the vehicle. So it solves a lot of problems, and I see that the technology is moving towards that. Why I would say that is because predominantly today we are using NMC and LFP chemistries, right? And NMC is used across water applications that we have seen, is used across performance vehicles, and LFP is used across the value-based vehicles, other applications in the mobility segment. And today, when we just go back on to the cell level or the chemistry level, the industry is trying to move away from cobalt because of a lot of other reasons, from politics, from the availability, from where we are mining, etc. And then there are other places where, because of the safety issue, because of the thermal stability of the chemistries, some places are going towards LFP, right? But finally, it comes to a point where what is the need of the vehicle at the vehicle level in terms of its performance, efficiency, and reliability. When we speak about that, today the cost that we are talking about is between 14 to 16 rupees per watt hour. Is the general expectation from the market, is what we have seen. But it is different for different types of applications and different types of vehicles. So what I see the technology moving towards in the next 5 years is that a proper diversification across the segment, in which there is going to be a performance segment of battery packs, purely from a battery pack perspective, not from a vehicle perspective, a performance battery pack, and purely a value-adding battery pack, where the range, the number of life cycles, the thermal stability is going to be the most important factor. Hence, depending on that, the technology is going to move. And we expect, because of the innovations that are happening at the cell level manufacturing and a lot of players coming into the market in building the cells, we expect the gap which is existing today between a good battery pack, which will be costing somewhere around 20 to 25 rupees per watt hour based on our analysis, versus the market expectation which is at 14 to 16. That 10 rupees gap is will be getting reduced. And because of that, we see the market adapting to well-to-wheel analysis, and then trying to standardize and diversify the battery pack requirements. And that will eventually end up in a lot of innovation in terms of, since the well is already kind of standardized to a larger extent, and that is, I think, one of the back-end reason why the swapping policy is also in place. But I would like to speak about the swapping policy a little later of this segment on the standards which have come up. But I think this will eventually help everyone in the battery pack industry in order to understand, manage the supply chain, work at the inventory, deliver the required battery packs into the market, and enable the faster adoption of the battery tech into the market. So we see standardization as one of the major aspects that is going to happen, and diversification of the market in terms of cell. Quickly on the BMS, today, yes, according to the same cost factor when we speak about, there is always an option to choose from a hardware, what we call it as a preventive circuit module, PCM in short, to a very smart BMS. There is always an option, but it depends upon, again, finally it comes down to the price that is expected in the market, and depending on the performance and range. When this diversification happens, then we can actually put a lot of innovation at the BMS level as well, because we know exactly if it is a performance vehicle, maybe we have to go to a zero harness battery pack design, versus putting a lot of sensors for a swappable battery pack. Let's say someone, we are also speaking about putting accelerometer sensor, drop sensors, because it's going to be interoperable, etc. Right? So these things will get differentiated properly, even from a BMS tech perspective. Generally, I think industry is also kind of seeing that when we are moving from NMC and LFP, I think there is a large love towards LFP chemistry today in the market because of the thermal stability concerns. And what is not very well understood, according to me, is that LFP chemistry is the voltage degradation is very flat. So you need, if your BMS is at plus or minus 5 millivolt accuracy, means you are going to have a range prediction error of 25%. Let's say in a 2 kilowatt battery pack, you are talking about 100 kilometer range in a two-wheeler. You are talking about 80 to 100 kilometers as a variation, which is a very large range for the team to work on. So when the industry is also moving towards LFP, the sensing accuracy of the AFEs which we use on the BMS, the kind of sensors that we put in, the accuracy of the sensing, the sensors which is going on to the cell level or module level, everything will be improving. So the technology will be completely switching based on the chemistries, and similarly in terms of supply chain and others as well. I see that the technology trend is very well closely related with the chemistry that we are adapting to, and depending on some of the panelists who are putting up larger factories at cell levels also, based on the decisions, I think the entire technology will be adapting towards the same. Thank you.
Thanks, Ganesh. Question remains the same for Hiren. So,
Right.
yeah.
Okay, so yeah, I mean, very interesting views. Let me give a little bit of background because I worked in Panasonic for 17 years and I'm promoting this technology since 2008. And 2008, I have seen NMC, I have seen NCA. And before it came for the launching, the Panasonic team was working on it since 1998. So what I'm trying to give you a perspective is, while we hear a lot of chemistries, from the lab to bring it to application, and from application to bring it to mass production, there is a gestation period of 7, 8, easily 9 years. So let's look at that because each cell has to reach a level of maturity, and once it reaches a level of maturity, it has to run into an application. After it reaches into the application, there are certifications, there are multiple tests, and from that application for going for mass production, there's another level of regulations and safety and so many other concerns. So let us understand that cycle first. While I always believe we are cell chemistry agnostic, I always believe that every application requires a different cell chemistry. So let's not try to fit, one size does not fit all. That there could be applications where the energy density requirement could be very high, and you cannot replace it with LFP, you cannot replace it with any chemistry that you want. So each chemistry will be having a different application requirement. If I talk about EV, there are three major problems that we need to address today. First one is the range anxiety. So definitely people are looking for longer range in terms of kilometers. So energy density requirement is very high. Two, temperature performance, because as a country, as a region, we are a tropical country. We have different terrains. Unlike other countries where terrains could be different but temperature is even. We have uneven temperatures, we have uneven terrains. So the variations are very high. So temperature performance. And third is a fast charge. I mean, no matter swap, no swap, whatever way you want to use the battery, there are these three basic and major problems which every electric vehicle has to resolve. So battery selection will come from this. Now coming to what is available to address these three problems, I think we missed out one chemistry, that is LTO. LTO has a fast charge, has a high C rate, good energy density. There is a lot of development which is happening in this space, and I feel once the cost points, the volumes are achieved, cost points coming down, this could be one chemistry that will really, and temperature performance is very, very stable, even better than LFP. So this is one area. Another is before the semi-solid comes, or before the solid-state battery comes, there are a lot of activities which are happening on quasi-solid or semi-solid. And I think if you ask me 5 years में quasi-solid आ जाएगा. Means semi-solid will be seeing the day of the light on the roads. And a lot of work is happening on the anode side. Silicon doping is one of the option. Graphene is one of the option. So basically, I feel it is too early to see the silicon anodes. It is too early, in 5 years at least, graphene anodes, but definitely beyond 2026, we'll definitely see those battery technologies coming. One important point which I want to highlight here, no matter what chemistry or what technology is coming, one important aspect will be data analytics, telematics, and how we understand the characteristic curves of the battery and how we relate it to electrical calculations and how we accurately convert those data into the SOH, the status of health or SOC levels, and how well we are able to monitor and control them. I think this is one part which is very ignored, or rather I would say overlooked, which is very, very important. So how to relate because battery is basically a chemical reaction, and how to relate that chemical reaction, what happens inside the battery, nobody can see. Even today, there are multiple grades of cells which are available. You cannot differentiate unless you are an expert or unless you do a spectrophere or spectroscopy. You cannot differentiate A plus, A minus. So these are areas which will come from the telematics, which will come from the data analytics. And I think there's a lot of scope in this area, as we go forward. So these are my views. Thank you.
With that, I think we have covered the first point regarding the upcoming trends, and I'm happy that all of us could give insights, and we have basically covered from design to cell chemistries to battery as a whole, and even the business models, what kind of batteries we can consider. Although swapping is something which we touched upon briefly, but that fixed versus swappable configurations and the aptness of that technology in terms of the regional requirements, and even based on the economic and demographic situation. As Hiren rightly said, there are so many variables which need, each isolated market has to have being analyzed according to all these factors put together. So we will move to the next question, which is basically what are the challenges faced by battery manufacturers, and what are your suggestions to resolve those challenges? This is basically a generic question. You all are in one way or another battery manufacturers and even cell manufacturers. So what are the top, say, 3 areas which you can identify that, okay, these are a lot of pain here. So, and what are your suggestions? Is it internal resolution? Is it external resolution? And as we have some of government agencies with us, both international and Indian, which have access to governments, maybe some thoughts can be also translated there. So now we'll reverse the, I would say, the question is set. I will start with Hiren first. So Hiren, just share your thoughts on what are the challenges which you are facing as a manufacturer.
So thanks for the reverse order now. One of the biggest problem which my friend here already shared is the requirement for the market is 24 to 25 rupees per watt-hour battery, but the expectation from the people or the manufacturers or the OEMs is 14 to 15 rupees per watt-hour. I think this is a very big challenge, and especially, and I'm not saying that there is anything wrong. Basically, there are wrong benchmarks which have been set, and every time we compare the cost. We have some cost references from Bloomberg. I have nothing against Bloomberg, but when they publish something and it is read by everybody, and they should give a disclaimer there that these are the prices for the volumes of 10 gigawatt hour or 20 gigawatt hour or 50 gigawatt hour. Okay, so because what happens is when these people publish the reports, it's read by everybody, and then those things get fixed into the minds of the consumer or the OEMs. And then they come to the battery manufacturers asking for those kind of prices. So this is one thing which we need to understand, what are our volumes. People are asking for 200 pieces, 500 pieces, and they're expecting price levels of what Bloomberg is talking. So one very big challenge is that, how to address. 2, we are not able to differentiate even today yet between apples and oranges. I mean, with no bad feelings for any other, respectfully, all manufacturers are good, I believe, but this is not a concern from the manufacturing perspective, but it is a concern from the regulatory and the manufacturing standards and the equilibrium perspective. Today we are not able to differentiate. I mean, there are very good manufacturers, but maybe and they follow excellent automotive grade standards, but probably they are not able to sell their product. So this is something which I feel is a very big bias. So I think everybody should be under one, treatment, under one umbrella, and everybody should be brought to that level of manufacturing standards, before we get into comparisons and stuff like that. Third is we don't have an ecosystem. When I'm saying ecosystem, I mean to say the raw materials, cell we import. So there are so many different impacts, that we have to go through. There is an import duty impact. There is a US dollar impact. There is, freight impact. And most of the guys who are here, I think we are all importing cells, no matter what, a Japanese cell or a Korean cell or a Chinese cell. We are all importing from China. Most of these guys have factories in China. So, we are dependent in a way. So all we have is what is there in our control is only the manufacturing setup and the manufacturing process, while everything else external is not supportive as of today. So it's a bit of a challenge. Market is up and down. If there is a continuous demand coming from the market, if there is a continuous offtake, then you can have a cycle. It may be a 2-month cycle, 3-month cycle, 6-month cycle, with a proper forecasting, with a proper. But here the industry right now is little turbulent. It is not organized in a way. So forecasts are up and down. Then you take risks, you take financial risks. Then you end up having stocks, inventories. I think everybody's smiling. So I think we have a common problem here. So I mean, these are the besides the other challenges that besides the other challenges of competing with import versus local manufacturing, there is no benefit today. Like if I am having a factory, I invested in a factory, and there is no differential in the duty, there is no differential in the GST. If I import the battery pack from China, I pay the same GST. So there is no advantage as such, and which I feel is a very big challenge for a manufacturer like us. So unless we create, number one, a market which is stable and mature and ready to take off the volumes. 2, we have an ecosystem which is supportive enough. 3, we have a better, facilities, or rather I would say incentives for local manufacturing in terms of taxations and other things. Probably, we will continue to face this challenge for another year or so.
Thanks, Hiren. And basically, there are many strong problems which you have mentioned, and there are many battery companies, by the way, in our community, and a major chunk of our members and participants have something to do with batteries. So I am very sure that there are a lot of alignments here. Now I will request Ganesh, if you have say any other points which you think that these are critical problems for any manufacturer. What do you?
Yeah, then I like the point you said, any other, because I think what Hiren sir have told, it's more like a summary of most of the problems that we are facing. But I'd like to focus on a couple of problems from a summary, like from generally. Let's say today, one of the major problems as a battery manufacturer that we are facing is the inventory carrying cost. Right? Predominantly, the cell cost is the major cost of the battery pack, and we have to carry at least 10 different cells across 2 different chemistries in multiple different form factors. Not the form factor it is, with different capacities, right? So hence we are a very strong supporter of standardization of particular, at least to a certain market like fleet, which is being adopted at a large scale for a particular capacity, and at least to a certain extent, because this will help us to kind of streamline and standardize our inventory, right? Purely from a battery manufacturer perspective, these are like internal issues, but still today. Today the market is more like all custom battery packs, and the quantity is somewhere around 500 packs per month, right? You cannot definitely import 500 cells from China, right? 500 into 200, that's the kind of cells from China. It is not possible. We have to buy it as containers, and we have to hold on to that inventory for a very long time until the numbers comes into picture. And we also make sure that we have to fulfill all the OEM requirements at a given point in time, right? Hence, so we are very strong supporter of standardization, and this is one of the major challenge, and that's one of the suggestion. And the second point I like very much, which is what also I wanted to speak about, is the difference between apple and oranges, right? Today, it's very difficult, even when you speak about cost, right? Leave that, I don't know where this term called grade A cell, the grade B cell, EV cell came from. Right? I always try to figure out the proper definition for what is grade A cell and grade B cell, right? So it is very difficult. Like today, we speak about when we do sorting, grading of the cells before building a battery pack or a module, right? We start from like plus or minus 50 millivolt to plus or minus 20 millivolt, like the OCD standards. And impedance we set range from plus or minus to 0.2 to 0.5 milliohms, right? So it depends, right? You can, I don't know whether you will call 0.1 milliohm different cell put together to make a pack as a grade A pack or grade B pack. If you ask me today, I don't have the answer, right? So starting from there all the way till to understand like what kind of the BMS that you put in, whether you need PCMs or BMSs, right? This is one of the major challenge. And when it comes to apple and oranges, so what generally the answers that I get is grade A, grade B, like you get it from a trader, the cell from a trader, and put it and make it as a battery pack. Maybe it's a grade B battery pack. You directly buy from China, it's a grade A battery pack. Means battery pack is not only where you buy cell from, right? That's not how a grade should be defined. And because of which, what happens, I know like this is very much related to the apple and oranges. You put lot of stringent measures starting from grading, sorting, and then capacity testing, performance testing, simulate the cell balancing at BMS level, test the BMSs before making a pack. This is the effort that a genuine manufacturer puts in, right? And then if there is a policy or if there is a way that government can recognize genuine manufacturers, just give a manufacturing ID, make a proper audit, right? Then maybe, I think it is not a tough job. It's very easy to differentiate between apple and oranges, and it is not even apple and orange, it's between apple and pumpkin or something. So it's very, very, very big difference, I'm telling you. It's not a very small difference that you can actually speak about. So that could be one of the way out to understand whether, this is one of the major problem for a battery manufacturer. And of course, like we spoke about cost, we spoke about thermal management, we spoke about multiple other factors. But still, I would press upon similarly standardization where we go from well-to-wheel analysis, because the starting of design and development of the application means at most of the times I felt it starts from the energy storage. So around that, the vehicle, the performance, the motor selection, the drivetrain, everything is built around that. The kind of power consumption, how much time you want to give. The fast charging, everything starts from that well, and hence I always believe standardization from moving from well to wheel analysis will help battery pack manufacturers to a larger extent, because investing on a manufacturing line, it is a very capex intensive business that we are into, and if we actually build a line for one battery pack, it is not very easy to build a modular line, and it is not very easy to shift. Means lot of OEMs are stuck today in single model of their vehicles. What I believe is because of their investment that they have done on the battery pack line. It may not be because of the change in technology, because of the market trend, but I think it is majorly because of the investment that they made in the battery pack line. Hence, we being a battery pack manufacturer, you see like we are building 10 projects every month, right? Can we build 10 battery pack lines every month? It's a very capex intensive business. So we try to become more modular, and for that we need to look into standardization. And that is something which we are looking at, and that is what we are aiming to achieve from policies that are coming up in terms of consultation exercise, right? That helps in actually we delivering things at a faster pace and able to help the market to fulfill all their requirements.
Thanks, Anish. And now I will request Vineet.
Sure. So again, I'll give a slightly different perspective. I mean, that all these techno-commercial challenges apart, I think one big challenge is people, right? Again, due to the fact that this is a technology in its infancy, and because of the profusion of interest in this technology, I think it is very difficult to find the people who have the right kind of expertise, the right kinds of insight and experience in handling all of these problems. So I think that is a really big challenge, developing capability amongst people. There are a couple of simple examples. I mean, if you take, let's take the battery pack manufacturing process. Amongst the many challenges there are, a simple thing, if you are doing a spot welding of the pack, how is the heat generated going to affect the jelly roll, right? If you get that, if you're not aware this could be a problem, it could have a significant impact on the user experience. And again, it's not because if I as a manufacturer don't care about it, it's just that I'm not aware of it. And that comes back to the fact that we don't have the people who can look at all of these things, who can consider all of these things. So there are many challenges that I can think of, but my point is that one big challenge is people with the right kind of expertise and experience. So yeah. I think I'll just stop there.
Thanks, Vineet.
Yes.
I think it's quite relevant. So we are talking about various domains and areas where we are all troubled. Obviously, talent is one bit. I don't think there's any entity in this forum which will say I am settled and I don't have problem with that. So that's a very good and important point. So we started with price. We moved to standardization. We talked about basically the talent bit. You can have all the fancy plans, but if there's no one to execute, there's no point in imagining those solutions. So thanks, Vineet, and now I will request Pratik. What is your assessment and understanding on the difficulties? And
so the difficulties and challenges across remain the same. What Hiren, Ganesh and Vineet have rightly mentioned. I'll put the challenges that we all are facing together in 3-4 points. Starting with price. The issue is that in India everything moves with price. They don't ask what you're putting inside the battery pack, what cell are being used. Very few OEMs go into such kind of details. The discussion doesn't start with what you're giving me, it starts with what price are you giving me. And then we reverse calculate and explain that these are the cells we are using, this is the BMS that we are going for, this is why the cost is so much. Certain battery packs are expensive, certain are cheaper. Why they are expensive, why they are cheaper, no one is getting into. And that's a major challenge. Second bigger challenge is supply chain. In terms of sourcing of cells, the price of cells are going up. So if we have some forward orders and you book some agreements, contracts, there's difficulty in terms of honoring them. If we honor them, we'll suffer significant amount of losses. So cell prices have gone up, I think 30-40% in the last 1 or 2 months itself. That is another avenue where we are facing some challenges. If we end up sourcing the right cell, end up sourcing the right BMS, there is issues in terms of freight. Getting the cell to India becomes a challenge because container booking, getting the shipping lines to book them at a particular price, getting them to India has been a very big challenge. We were paying somewhere around 50,000 rupees in 2009 per container. Today we are paying around 6 lakh or 5 lakh rupees per container. So it's gone up 1000% in the last 3 years. And India being a price sensitive market, everything can't be passed on to the consumer. So they will accept to a certain level. Beyond that, then you might have to work around it to survive in the market. So that's another challenge. Third challenge being the lack of awareness, I would say, in the market. That today consumers are getting into the EV business, but there is very little awareness about what should be done and what should be bought rather. So in terms of the end consumer who are buying the scooters or buying the rickshaws, running them, so when you're working with them, they are unaware that what is good for them, what is bad for them. So that awareness campaign has to be done at an industry level to explain to them that what they should buy, what they should not buy. That will solve some problems. I don't know if it will work in our country or no, considering we are a price sensitive country, but it's one avenue where no one's focused upon. So that's one challenge. Yeah, there's one positive that at least the industry is collaborating. We are looking at multiple stakeholders today, BMS suppliers, there is standardization that each and everyone is willing to use different type of cell manufacturers, different type of BMSs, different technologies coming together, selling the battery pack. So there is a great level of collaboration in the industry. That's why I think it's surviving to an extent. Otherwise, if everyone tries to do everything on their own, it will become a very big challenge to continue and survive. So that's one positive that we feel. In fact, our take on this is that we are not looking at this as an auto component industry at all. The parallel we can draw to the battery pack manufacturing is to the likes of laptop manufacturing or electronics per se, wherein the likes of Dell, Lenovo went with a Pentium processor, they went with Microsoft OS. Similarly, a battery pack manufacturer will collaborate with a different BMS, will collaborate with a different cell manufacturer and get the product out, operate it and give service. So that is our view on the entire industry rather than being an auto component traditional space that it was before.
thanks, Pratik. And I'm glad that while we have companies and experts which are heavily experts in the technology bit, we also have companies which have customers or customer-centric approach and service-centric approach also. And I'm happy that Pratik is here. And while Pratik has given the introduction already, there are very few companies which are doing well, in as far as the customer support and enablement to customers is concerned. So with that point of view, I am aligned with what Prateek said. When we discuss about pricing, we discuss about technology. There's a major chunk which is about customer service, what companies, your B2B customers or your B2C customers want. And it's an innovative way to think batteries beyond automotive component and see it as a consumable or a device which can have multiple roles. Like maybe in future you might have battery packs which can be not only used in vehicles, but you can also use it as a power bank to charge your laptops and whatnot. So there are multiple configurations which are possible. So with that, now I will request Naveen, as the manufacturer and both for cells and battery now. What are your views on the challenges which your company might be facing, or what is your view that the industry as a whole is facing, and what can be some remedies or solutions to it?
Yeah. So I accept what they said. So it's a universal problem. So in addition to that, how we can design a battery pack for Indian tropical condition is the biggest problem. So because cells which we are procuring it is designed by the Nobel Regret sitting in Japan and USA. They don't know about India. So the current biggest problem is that how we can design a safer battery pack for Indian tropical condition. So the answer can be like, can we have a cell which can design to our Indian condition, but we can take. Because a few weeks back, Vilas is here, so I was test driving his vehicle, and that vehicle has our battery pack, and the temperature is already 43. I was worried whether I need to do test ride or not. I was little worried because this cell has cut off at 60.
Yes.
What will happen after that? So I think this is the biggest problem. We need an Indian cell. So that is where Excite is trying to work towards that. Even though the cells from Samsung, the brands which we use, right, may not be suitable for Indian condition. So we need to look in that direction, and that challenges we need to address. Rest of the problem is a universal problem, right?
Thanks, Naveen. I think it's quite an important input. Temperatures in Indian ambient conditions, and not only temperatures, even humidity, road conditions, vibrations, theft, accidents. There are a number of other factors which are not generally found in other geographies of world. And I like the idea of localized technology as far as lithium-ion cell is concerned. Until that is achieved, I think all of you are already aware, and with various, I would say, stopgap or even some approaches to bypass that risk element, which is there, using cells which are not tuned to the tropical environment at least. And we have also spoken to multiple companies which are operating in different other locations coming to India. Everybody has this concern of temperature. When they want to launch their international vehicle in India, one of the line items of concern which they want to verify is obviously thermal management and how the cells will behave, and whether they can basically arrange the safety bit of the batteries also. So thanks for basically with this we have closed the second point. The third question from the community is what will be your suggestion for vehicle manufacturers and fleet operators? Now this is a very interesting question. You all are battery manufacturers, and we have various vehicle manufacturers here. And as we are recording the session, and we will document and maybe share it with various other OEMs also. This is a good platform for you all to share. What will be your suggestion for vehicle manufacturers? Like there are various problems you have already mentioned where the other side, the customer side, can help. Or similarly, so I will again start with the original trend. So I will ask Naveen, what will be your suggestion to the CTOs and senior leaders which vehicle manufacturers are here as a battery manufacturer, which like to give, so that when they are developing their vehicles or they are designing their next set of vehicles, they should keep in mind as empirical rules or as a suggestion which will keep their life easy, or they will find their battery solutions faster. What do you?
Yeah. So as a battery manufacturer, we call battery as a source of energy, right? We can store the energy, then we can give it back. So for the OEM, they measure the same energy in terms of range, how much range it will give. So in that case, like energy is limited, so we can offer limited energy, and how they effectively use it to make it convert into range is a very important element. In that, the energy management is very key, right? So there are a lot of aspects. The current trend is that, oh, we have a gasoline vehicle, a diesel powered vehicle, let's convert it to electric vehicle. Okay? So the problem is that we lose an opportunity that we could have reduced the weight because we don't have engine, we have a smaller motor now. So battery pack has shifted in the middle, okay? It can give more strength to the dynamics of the vehicle, okay? Can we reduce the structure? That option, we lose that option. And also we lose the option of, we could have more the aerodynamic, right? If you see our conventional, the three-wheelers or something like we convert from, it looks lame because for me, like electric vehicles should looks more glamorous than conventional vehicles, right? That is where the aerodynamics comes into picture. So only addressing with the aerodynamic and reducing the mass and reducing the wheel friction, we can bring almost 15 to 18% of range improvement. Okay? So I think that is something I request OEM to look for it. That is one suggestion on my side. The other one is that please do proper validation. Please allow us to do proper validation at our site. Okay, it's like I see time plan like, okay, we need vehicle needs to be homologated within 2 quarters. Okay. That is something like OEMs come with their requirement. That cannot happen because we cannot release, because we cannot test all the load cases in our lab.
Yes.
So most of the things we need to do on road. So I request OEMs to please allow us to test on your vehicle real road condition, and because everyone is learning, we are all learning from. So I think I suggest I give an opportunity for others to speak over here.
Thanks, Naveen. No, I really appreciate the feedback with respect to integration or testing validation. This is surely, unless if you cannot measure, you cannot improve. You know, many people use that phrase. So testing validation is very, very important to make your products professional. And one thing which typically startups, many startups I have seen personally, is the project timelines. You know, automotive development, traditional automotive development is quite a long, tedious process. That's where startups innovate and make it less. But there has to be some realistic expectations, some framework where if you are taking a decision to speed up things, you are losing some, I would say safety aspects. That trade-offs should be made available so that the vehicle manufacturer or the decision maker, which is now placing orders to you, is informed that what is being asked. So still, I'm very sure that as an engineer, you are more than capable to even meet 6-month timelines, but then many unknowns will not be addressed. And that is where, the chaos and I would say situation arises, which many of us have seen. So thanks, Naveen. I think that's a very incredible point to be raised to startups. If you are starting up product developments, I think there should be long-term thinking. If you are developing a product 3 years down the line, you should start preparing for what kind of battery pack technology, what kind of energy evolution will happen, and then interact with your suppliers, battery manufacturers to see those time horizons, how they can be met. That will be far more easier for all of us to settle than end stage or last stage scrambling of finding batteries. Now I will request Prateek, questions remain the same. You have been interacting with vehicle manufacturers. What will be your suggestion, to help both sides?
The biggest suggestion that we would like to give to vehicle manufacturers today is to involve us when they are starting the prototype stage, at the design stage itself. The issue that is happening today in the market is most of the OEMs have a larger storage space and a lesser space for the battery. And because of that obsession with compactness for the battery, there is tremendous amount of pressure on the battery pack manufacturers to meet that dimension requirement. And if you don't meet them, you're not going to supply the battery pack, that's clear. So to meet that, either you will have to go for a very high energy density cell to meet that requirement, or you let that business go. And then you will be forced to take decisions like going with cells which might not be conducive for the Indian conditions. And now the market trend is slowly shifting towards LFP. We all know that LFP battery packs are more voluminous than NMC battery packs, at least it will occupy 30%, 40% more area. So a lot of these vehicle manufacturers that have designed their vehicles and the molds as per NMC, they're finding it difficult to move or shift. Considering that the battery technology is also not stable today, we should involve them at day zero so that at least the prototype has that much customization available in the future if they want to move from A to B or B to C. That is one major suggestion that we would want to give them. I understand there are challenges in terms of the price they have to hit the market at and the range they would have to give because everyone's competing. But this problem would be solved if we all are involved at the prototype stage itself. So that is one suggestion. And in terms of fleet operators, standardization is one issue. And a lot of fleet operators have gone with NMC chemistry for the swapping players have gone with NMC chemistry. So, I mean, if the whole idea of swapping is that we are defeating range anxiety, then you don't need to really use NMC. You can do away with LFP also, which will be way safer, considering the amount of battery packs that have been kept across the city. So these are the certain things that we feel they are incorrect at, and it's very difficult to convince them otherwise because they have made certain investments in that particular field. So it's difficult to move for them to move from what they have done before to what we are suggesting now. So it's best to get involved at day zero so that their solutions are better and it will give them more flexibility to move from a different technology to the other.
Thanks, Pradeep. And although we are arriving at the closure, so I have to keep discussion slightly tight. So I will let you to basically go next and provide your suggestion.
Yes, absolutely. I'll try to be quick. So I am in complete agreement. I just want to emphasize, I think we started the session with Mr. Anand saying that, R&D has to be integrated into the companies and stuff like that. And that would be my first suggestion. Make initial R&D a part of the entire product development process, because a lot of times I think with the pressure to go to market soon, it's easy to say, okay, let's figure out the R&D later, or the cell manufacturer has done their bit and they will worry about the degradation and stuff like that. But I think it's important to understand that OEMs have to invest in the initial R&D to do the testing, as Mr. Naveen mentioned. And of course, there are pressures in testing, so use simulation. But the thing with the batteries is, especially with batteries, is that pure traditional simulation is not good enough. So you need to invest in experiments.
Yes.
So you have to do some amount of experimentation. A lot of people think, I don't have the time for experiments. But I think that those few months that you spend on experimentation may help you, take care of a lot of problems for the few upcoming years. And so one thing I think which is very important, absolutely correct, most of the technologies that we use are technologies which have been designed for the West. A simple example is vibrations you talked about, right? It's a very good example because there's people in the West have done research on this, and the conclusion is we don't need to worry about vibrations, right? But that's because they have done it for Western conditions. But we do know that electrodes undergo stresses, and that causes degradation in cells. And in India, especially in rural conditions, your cells may be subject to continuous vibration stresses, which can lead to degradation. Today, nobody knows about these things. So integrating R&D, doing predictive analysis is important. And another suggestion I have is collaborate, like you mentioned, collaborate and share data. Because coming up with standard experimental procedures and sharing data across manufacturers can take us all along with. Right now, I don't see that happening, but if that can happen, I think everybody can move along faster. So that's what I would say.
Thanks, Vineet.
Yeah.
And over to you, Ganesh.
Yeah, I think what I would say, Mr. Naveen and Nexcharge is very much blessed to have 2 quarters of time. We generally get less than 2 weeks kind of timelines.
Expectation of startups.
Yes, 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 that is always there. And also, I will very well agree with Pratik also. Even the battery pack which is already designed by the OEM cannot be replicated by battery manufacturer again. The reason why I am saying that because it has multiple perspectives. What we expect, maybe I'll be very quick on asking what I wanted from vehicle manufacturer very clearly.
Yes.
So I wanted specifications, very clear specifications. So what are the specifications I want? I wanted to spend a lot of time on the specification. The specification that I want is today, we put a lot of focus on the product specification. I need a lot of specification on the process as well. What are you looking at from the process side? What is the kind of fulfillment that you're looking at? What is the CP/CPK? Like, what is the kind of failure rates that you're looking at, right? What is the kind of money that you're willing to put on the capex on the tooling side? I think as a battery manufacturer, we generally don't get this kind of specification very clearly. The another specification that we don't get very clearly, and why it always takes us to back calculate and takes a lot of time for us to arrive at a specification, is another thing is the degradation perspective, the depth of discharge at the end of life. Like, what is the degradation that you're looking forward to? What is the usable capacity that you want to give it to your customers at the end of the life? I know that today you want to give 80 kilometers range, right? After 3000 cycles, let's say for example in LFP, and what is the kind of expectation that you have, that the range that you can give to your customer at the end of the life? We don't get this specification. And another important thing that I would like to say is that changing one cell from to another cell is not a one-day kind of a change at all. It is something which we generally get. We look at specification, designing, development on a particular cell, and that means I definitely don't underestimate, or I definitely respect what are the challenges that OEMs goes through. But just in case if you decide that if there is a change in specification and tomorrow you want to give higher capacity pack, but in the same volume, right, and you want to change from a cell with lower energy density to higher energy density, means it is not a one-day change for us. From a battery manufacturer perspective, characterization of cell takes a lot of cell experts are also here. A lot of characterization of cell testing from an application perspective takes at least 3 months in order to at least simulate the Indian drive cycle, which is predominantly accepted across the industry, and find out whether the cell is suitable for the application that you're asking for against the specifications.
Yes.
Right. So that's another thing. Right. Means also let us also iterate a couple of designs. Right, means first time right is today, as everyone, all the experts were saying, panelists also. Today we are also learning, right, and there are a lot of assumptions and thumb rules which goes into even the internals of the battery pack design. Of course, we would like to try and see the maximum effort, put maximum efforts over there. But still, I would suggest, also request from vehicle manufacturers, if you can allow us to also do an iteration. That will be really helpful for us to achieve a better or best battery pack for the application that you are asking for.
Thanks, Ganesh. I know that's a very important point. Basically, ad hoc changes might have very profound results, sometimes not so positive. Great inputs, Ganesh. Over to you. Hey.
Yeah, so Hiten, I will keep it very short and simple. I agree to some comments which Mr. Bajaj made in a couple of forums, and he says that most of these EV manufacturers don't have an automotive DNA. So I think I will start with that first, because if you want to make an EV, you need to understand the dynamics of how an automotive industry works. If you have that DNA and you change your approach, then you are able to address everything in a very good way. So in an automotive industry, they first select the engine, then they design the chassis around it, and then they do the rest of the things, the beautification, aerodynamics and everything. I think here what happens is, people will start designing the electric vehicle, and then I have this slot available, I want to put in a battery there. So I think this is something which approach needs to be changed. I reject, people send me RFQ. I reject that RFQ. I say I don't want to quote. You already have a battery pack. You involve me when you're starting the design, and you tell me what you want to do, and then I will work out with you. So this is something which is very fundamental. And not only the battery pack is one aspect. Once you have frozen what exactly you want the vehicle to be, and once you have frozen what the vehicle has to be,
yes,
then you have to work on the other aspects of the vehicle also. You cannot load everything on the vehicle, on the battery pack. So I have an Nexcharge, I have an electric vehicle, I have an Nexcharge, I use it, and I'm very disappointed. I mean, the vehicle is very good, it's fantastic, everything is is amazing. It's a good electric vehicle. The only reason why it is not able to perform on the road or is not able to give the range is because they chose the chassis which was for ICE engine.
Yes.
I mean, this is something which is really, fundamentally wrong. Your tires need to be different. Your shock absorbers need to be different. Your interiors need to be different. Your exterior needs to be different. I mean, just by painting it blue color, white color, red color, it's not going to make it an EV. You change the design of an ICE engine to a dedicated electric vehicle design. And that is where we come from. I mean, you can, and then with such a bulky body, you are loading it on a 30 kilowatt hour battery. I mean, how is it going to give you a range? Very simple. So that DNA and that approach of an automotive, that is the starting point. Second, for the fleet operators, I think it's high time. I've already spoken on a lot of forums, and I've also suggested, like you suggested to Niti Aayog and stuff like that. I think it's high time that we come on a common platform. I think when internet was evolving and we came on a www, I think it's high time that we all come on one platform, one common platform, which is a digitalization of the energy industry, may it be electric vehicle or VSS or whatever it is. One common platform, and everything comes on that, and from there it goes, it can go to Google or Windows or XYZ, whatever it is. I think that is one area where it's really high time that we need to do something, and we need to have a common digitalization platform. So I think these are my two requests.
Thanks, Glenn. I think we have one more question, but in the lack of time, we will basically wrap up. We have a couple of demos lined up. I would like all our participants and community to see those. Meanwhile, after the session is over, there is a networking session arranged, and I'm hoping that through this discussion which we have today, all of you who are here will have food for thought. There are basically various companies which may not have ever thought of the challenges in the other side of the story. Like there are vehicle smart companies here, motor manufacturers here. So I think there's a good opportunity for you to basically speak and see how some of these very incredible insights which you have shared today can be basically implemented in automotive industry in a fashion which is more professional and I would say effective. So I would request a great, I would say round of applause for our panelists today. Thank you for. Next, we will proceed towards the product demo. We have, some of our panelists which would like to present the product portfolio they have, and some of our international visitors are also here. We have, we will require your attention there also to explore the products. We will start with Neuron Energy. I think I will request Pratik to walk us through the presentation, and I will request my teammate to put up the presentation of Neuron Energy. Over to you, Pratik.
So I'll just introduce Neuron Energy and what all we do at Neuron. Our focus have been 3 application areas where we have decided to design our battery packs. The main focus applications have been electric 2-wheelers, electric 3-wheelers and golf carts. We started off in 2018 selling lead acid batteries for golf carts, and then we moved on to lithium ion in 2020. We started with lead acid as a lead acid EV focused company only, with an idea that we will serve the e-rickshaw market, electric 2-wheeler market and golf cart market. The idea of starting with lead acid was to own the consumers with the lead acid business and then eventually serve them, building a sales service distribution network to ensure that serviceability is taken care of, because that's the key area in the battery industry. In terms of lead acid, serviceability is important because the after sales market is fairly larger than the OEM market, unless what we see in lithium today, where it's a pure OEM B2B play right now. So keeping that in mind, we built our distribution network across UP, BR, Jharkhand, West Bengal, Delhi, North India. And then we focused upon 3 segments which will serve into this market. That was electric 3-wheelers, electric 2-wheelers and golf carts. And then slowly we have evolved into multiple other applications which demand comes from the same particular zone or the areas. And we have been working on the battery packs to feed this location. Since 2019-20, we have completely focused on lithium. And right now in lithium ion, we are selling somewhere around 1500 to 2500 battery packs a month. And in electric three-wheeler, we are selling anywhere between 500 to 700 battery packs a month for L3 category. So in the electric two-wheeler battery pack, we are using a smart BMS. All our sales have been with a smart BMS. We haven't sold anything yet with a MOSFET-based basic BMS. However, considering the price pressures right now in the market, we are looking at multiple opportunities, but right now our product comes with a smart BMS. There are 4 temperature sensors. We are putting a vibration pad on all 4 sides and included in the bottom of the battery pack. We are using, it's a Bluetooth enabled battery, so we can remotely repair the battery anywhere in India within an hour. So the software related issues can be solved at multiple ends of the customer level through the app itself. Over and above that, all the materials that we are using inside the battery pack are FR grade materials. And the main idea of remote assistance is that to ensure, since each EVs have a different use and they are being used in different terrains, customers are facing various issues regarding batteries, but they are not related per se to the batteries, but to the settings that we put in the BMS. So the smart BMS allows us to change the settings remotely to ensure that this problem can be solved within an hour or 2 hours from the time the call is logged. We are spending tremendous amount of money on the smart BMS compared to a basic BMS. However, we are giving this option of basic BMS to a certain clients now where we know that there is a standardization or a fixed module that they require. Over and above that, in the market we are only selling battery packs with smart BMS. Now, electric three-wheeler battery pack, currently we are selling 160 Ah for L5 category and 8600 Ah for L3 category vehicles. Each and every battery pack comes with a GPRS tracker and Bluetooth enabled smart BMS to enable us to solve the battery and track the battery. Here, GPRS tracker has been a boon to us considering the usage of in this three-wheeler manufacturing. Range becomes a very big issue because their livelihood depends on their daily range that they have. So this is a very difficult segment to cater to. We are using a futuristic technology battery packs for a consumer who is unaware about the technology. So we get random calls regarding the servicing in these battery packs, and the consumers here have to be tackled in a very different manner because if they don't run the rickshaws for 2 days, it might impact their livelihood in a large way. So if our battery packs are giving them a 50-kilometer range rather than 100-kilometer range, they might go home without any food. So it's very critical to understand what we can put in the battery pack here and which all features. We have put a GPRS tracker only to ensure, to show them through a portal that this is what your run is daily. And that has helped us solve many problems with the consumer in this segment. In terms of the value proposition, it's because it's a smarter BMS, we can control the DOD. We are keeping the DOD at 80%, and then we had issues with the market telling us that your battery pack is not giving us enough range, and we have to change our DOD to 90%. Even then, we are not going above 90. Most other battery packs in the market are at 100%, which is an issue because after life, as Ganesh rightly mentioned, after the life of the battery pack is over, it will have range degradation of around 40-50% if we have 100% DOD. So that is what we are trying to protect. And remote service assistance through the app is another key feature that we are trying to reach out to people with to ensure that if there is a problem, we are there and we are solving it within a stipulated time period. In this day and age, we can't sell a battery pack sitting here in Bangalore to Delhi and then say that you send it back to Bangalore, we will repair and send it back, which will take a month. That's won't be acceptable. But consumers are willing to pay for this, and that's why we have integrated it with our battery packs right now. So that is the products that we are focusing on in the application areas. Neuron moving forward will look at charging business as well, but only focused on EVs. Neuron Energy does not have a product portfolio when it comes to solar or any other application. we are an EV focused company and our entire infrastructure of supply chain, service and logistics is built as per the EV industry. So it will be very difficult for Neuron to move away from that and move into other applications of batteries. That's all from our end. Thank you.
Thank you, Pratik, for your presentation. The next company which will present a brief introduction is Nexcharge. We have Urja Energy, and I will request Vineet to maybe basically walk us through the presentation.
Good afternoon, everyone. My name is Vineet, and my co-founder Prajakta is also here with me today. We founded this company in March, so we are a very young company, and our goal, like I said, is to simplify the entire design process. So I used to work for a company called Comsol. I founded and headed their Indian operations for about 13 years. And I always had this nagging feeling, we used to do development in India, but the IP always used to go outside India. And if you look at the entire software computing industry, the way people view India is as users of scientific computing softwares. They never look at us as people who can create our own software. And I don't see why not, because we have some of the best modelers in the world, we have some of the best researchers in the world. In fact, if you look at all of these developers in these software companies, non-Indian software companies which make products, they are mostly Indian, but the IP is always outside India. So we decided, let us bring together the entire research community in India. Let's create a world-class software out of India. That's our goal, really, as simple as that. Of course, I'll get into why we started with batteries and so on and so forth soon, and our approach as well. So when it comes to batteries and to EVs, you know that batteries are one of the most important or expensive component of an electric vehicle, ranging anywhere from 30 to 40%. And like I said earlier today, there are some specific challenges when it comes to predictive analysis of batteries. All of you, I'm sure, are familiar with different kinds of analyses, CFD, heat transfer, structural mechanics. These are well-established branches, you know how to do it. Unfortunately for us, batteries don't fit into that bucket, and there's a reason why. So if you can move to the next slide, I can show you. Some of the challenges which I'm sure all of you may have encountered is when you're designing battery packs, when you're designing packs is, how am I going to design the pack? What is the spacing between the cells going to be? What kind of filler material should I use? What kind of cooling strategy should I use? We talked about different temperatures and different gradients or different terrains in India. So if it's a fleet, or if it's fleet operator, I'm operating in Delhi versus operating in Bangalore at different drive cycles, how is that going to impact my battery performance? These are questions to which it's very difficult to find an answer at the design stage, when you have very little to no access to any data, right? So how do you do predictive analysis at this stage? It's very difficult. If you can move to the next slide, please. Thanks. And this is, I just want to say that this is a universal problem. So this is not a problem which only startups face or young companies face. Whether you are an established company or a startup, irrespective of which stage of your life you are in, it's a universal problem. And the only, the only way you can get around it really is to spend a lot of money and a lot of time in doing experimentation to get data. But of course, there's an intense pressure to get to market fast, and that is what leads to inefficient design. And like I said earlier, it's not intentional. It's a byproduct of the times you're living in, the pressure to go to market, the lack of expertise that we have today. It leads to suboptimal products, which may lead to design defects, and that is the challenge that we face here today. So today, if you look at anybody who wants to design a battery pack, what is the process that they follow? This is how they do it. First, you decide on what cells you want to use for your battery pack, and then you have to do predictive analysis if you want to design an optimal pack. Now, the way you do that is first, like I said, you can't do pure physical analysis on cells, because cells are a unique animal. For CFD or structural mechanics or electromagnetics, you have material properties for whatever you are designing. And these are well-established properties. Everybody knows that they are publicly available. Unfortunately, at the cell level itself, there are upwards of 20 unknown parameters. lot of things. It could be the porosity of the cell, the conductivity of the cell, the kinetic, electrochemical parameters, the kinetics that are happening at the electrode-electrolyte interface. All of these are unknowns. And most of the times, the cell manufacturer will not share it with you because these are proprietary materials. So in order to extract these, first of all, you have to take permission to cut open a cell. And if you get that permission, then you have to do some experiments to extract parameters. And only when you do that, can you then do accurate physical analysis. So pure physical analysis also involves experimentation, and it can take upwards of 6 months to do that. The other way you can do it is rely on data. You do experiments, like you were saying, run it on the field and you get experimental results and then do the design. But the drawback with that is that it's very time consuming, and we don't have the time to do months and months or sometimes even years of experiments, especially if you're talking about degradation. And therefore, at Urja, what we have proposed is a hybrid solution. So this is the first commercial tool in the market which is proposing this solution. So very quickly, just to highlight what this hybrid method means. The traditional approach to simulation is, if you want more accuracy, you add complexity to the model, right? Now this complexity could be in terms of adding more features to your geometry, or increasing the number of physics you're solving together to make it more real life, or increasing the mesh of the problem, whatever it is. But it's simple. Make it more complex so you make it more accurate. Now the hybrid approach gives you a paradigm shift on this. So in the hybrid approach, you use a combination of physics-based modeling and machine learning. So the way this is advantageous is, the physics-based approach is used only for the initial solution space. So one of the biggest challenges with using pure machine learning for predictive analysis of physical systems is that it's prone to overfitting. So very simply put, what overfitting means is, in machine learning you train and then you predict. So for training you need some data. When you use the training data, it gives you good results. But when you predict it on something outside of the training data, you get incorrect results. That is called overfitting. And this happens because physical systems are highly nonlinear. So you could reach a local minima during your training and not the global minimum, which is the accurate solution. Now the way the hybrid method overcomes this problem is that the initial physics model is quick and dirty. It's an approximate model. So you don't need accurate parameters to set this up, because all you're doing with the physics model is setting up the right solution space. And the accuracy then comes from experimental data. So it's your experimental data which will give you the accuracy and accurate results. So from a paradigm which says add complexity to get more accuracy, the hybrid model tells you simplify it, do a little bit of experimentation, and that will give you accuracy. And again, the advantage with experimentation here again is that you don't need months and months of experiments. A few days or a few weeks of experiments are enough, because this initial pre-training is done by the physics-based algorithm. So that's what we are doing in our software in Urja. And once again, like I said, we want to simplify the entire design process. So traditionally, you need experts to do the modeling. You need months to get trained on the software, and then you need months to get meaningful results. Our goal is to ensure that the day you start using our software, you will be able to get meaningful results. So first of all, we are going to deploy it as a SaaS, a software as a service. So you can log on anytime. You don't need to invest in, it's not a capex investment. You don't need to buy the software. You just log on, and it's a very intuitive interface. So it's intuitive input, intuitive output. In the background, of course, we are doing all of the physical models, the electrochemical, heat transfer, CFD, machine learning. Everything's happening in the background. But as a user, you don't see it in the foreground. So I don't know if we actually, we can show the interface to you, because it's online, like I said. So all of you can check it out. You can log on to app.urja.energy. Yeah, so we can quickly run you. So this is how the interface looks. You can just log on. If you could please log on. Yeah, okay, awesome. So she's logged on, and then we have two products. One is for thermal management, the other is for capacity fade. So if you go to thermal management, you can start a project. And so there are two, like I said, because it's a machine learning approach, you have two steps. First you train, and once you have a trained model, you do the prediction. So the training is at the cell level, and prediction is at the pack level. So in the training, you see, you can, this is how the interface looks. So you can choose your electrode chemistry, And all of this is data that you will find on the spreadsheet of your cell. So it's easily available data. And then you also need to upload some experimental data. So for thermal management, we need HPPC data, which is again data which you can get in 24 to 48 hours, depending on how extensive you want it to be. So you can get your data, or if you don't have your own HPPC data, we are also building our own HPPC database. And you can use our HPPC data for the cells that you are using. So this way you train the model, and once the model is trained, then you start doing the prediction. So in the prediction page, you can choose the cell for which you've done the training, and then you can add the number of cells that you want in your pack. You can choose the what kind of spacing you want between the cells, the packing material, whether it's air or it's some filler material, a PCM. You can also add a cooling strategy, if it's air cooled or liquid cooled, whatever it is. And then you can also add the initial ambient temperature with the drive cycle. So you can choose different drive cycles. And once you do that, you can then predict. And once the prediction is done, you can view the results online as well. So you can see what is the temperature of each of the cells, the delta T in the pack, the progression of the delta T, the voltage in the pack. All of these are things which you can see very quickly. So with very little effort, with very little experimentation, you can get accurate results. Similarly, you can do the same thing for capacity fade as well. So again, I don't want to go through all the details here, but same thing. You can do the training first, and then you can go to the prediction page. Again, you'll have to upload cycle data here. And we've done some stress testing where even with 20 cycles, you can get up to 90% accuracy up to about 1,000 cycles. So here you can predict the capacity fade for different C rates then. So this is how the software is. Of course, I've rushed through the whole thing, but if any of you are interested, I would love to explain it in more detail later on. Yeah, if you can just finish the presentation now. So yeah, this is how the software looks, and like I said, we genuinely want to disrupt the entire way you approach design and simplify the entire design process. So you can see we've tried to make it as easy as possible for you to use. We've done a lot of validation. I don't want to show you all the validation, but if you can scroll down, you can see we've compared it for packs, for different real-life drive cycles. We've done the validation. Yeah, you can scroll down. Even for capacity fade, we've done the validation. So these are some results, but there are many more which I can share with you later on if you're interested. And like I said, disrupt not only the way you view software, but like I said, you won't need an expert to use these softwares. And also the way you deploy them. So it will be SaaS, you don't need to invest in expensive equipment. And if you can scroll down, please. So even the deployment model, okay, so just to summarize, it's easy to use, it's intuitive, we have fast and accurate solvers, we have a built-in database, and we have experts available in Bangalore if you have any questions. So if you can scroll down, please. And even the way you use it is you don't need to commit to a long-term investment to using the software. So it's a per month usage. You want to use it for 2 months in a year, you need to pay only for 2 months. And then you come back only the next time you want to design your battery pack or something. So this is, yeah, we'd love to engage more with all of you and explore how we can help you. Thanks a lot. Thank you.
Thanks, Vineet. Glad to see software, hardware, both technologies merging together and coming up with optimizations which are quite interesting.
First of all, I would like to thank Hiten and his team and Micelio in general for providing us the opportunity. By the way, Micelio is already a user and they have a Comsol license at Micelio Studio. And Vineet also worked at Comsol for more than a decade. And so just wanted to move on to this, yeah. So Comsol is a well-known tool for multi-physics simulations, and it originated in Stockholm, Sweden in 1986. So we are across the world and we have roughly about 100,000 users across the world. So today I just wanted to focus on the capabilities of Comsol for EVs and how Comsol, being a CAE platform, can cater to the needs of people from the design teams, people from the CAE teams, as well as testing and validation teams. It's a fully integrated suite. As you can see, everything is done in the same graphical user interface, from the CAD to the geometry and the materials and the physics and then the solving part of it. So this is what a traditional tool does. I mean, the users in the industry, when they make a model for a new product, for instance, a battery pack, so they will first need a CAD, they'll assign some materials, if the materials are in the tool, and then they will assign the physics, they will solve it, they will post-process it. So this is the flow. But Comsol takes it to one step ahead, because once the model is ready, which is made by the experts, we can take it to one step ahead and make it more user-friendly, intuitive, into a form of an application which can be used by anyone across the design teams, the CA teams, the validation teams. Here, the inputs and the outputs are carefully designed so that one can insert, or rather, check out various what if scenarios. For instance, what should be the density, what should be the diameter, or what should be the diameter of the battery cell, and find out the performance of the battery pack very quickly. Here another application demo for a wire harness model. And similarly, the inputs and the outputs are controlled by the user, but it can be used to run various iterations in a short span of time and find out the actual performance of the device when it will operate in the real multiphysics scenario. So this is what I wanted to highlight. For instance, there are some market needs in EVs. The needs keep on changing, evolving all the time. So the product specifications has been obtained for a new, let us say, model of an EV. So traditionally what will happen, the designers will make a design, they will send 4 or 5 designs to the CA teams, they will work on that, do the physics analysis. The designs will then travel to testing and validation. If something fails here, it has to go back to the design route altogether. And it's a investment of time, energy, effort, because typically the design to testing prototyping takes roughly between 1 to 3 years. But what Comsol can offer is, using our applications, the designs can include some basic physics level calculations in them. So the designs will be improved ones, more optimized ones. And when they travel to the CE teams, they can also build on those apps and do a detailed analysis. And the rate of failure when it reaches testing and validation will reduce drastically, thus improving the overall prototyping process to reach the prototype for a particular project specifications, and thus cutting down the design time significantly. This is a case study which was done by Fiat, where they wanted to optimize the thermal management of battery packs. So Comsol is being used for battery modeling for almost 20 years, primarily in European and US markets, because they developed or matured quickly. So here they were able to reduce the design time by up to 70% using Comsol for the power cell which is being shown. Another one from Volkswagen, they were trying to build a motor, but the problem that they had is that they wanted to balance out the mechanical loading as well as electromagnetics in the motor, and using applications. Now this is an example of application. They were able to distribute the apps throughout their teams and cut down the design time and get to the results what they wanted. Another from Next Energy startup, they wanted to find out which welding method, when for the battery packs, will be more suitable. Will it be spot welding? Will it be laser welding? And they found out that the elevated temperatures may cause irreparable damage to the battery in the spot welding case. So using that, they were able to determine that laser welding is perhaps a better suitable method for this application. Mahindra, another big user of Comsol at MRV Chennai. So they build applications specifically for chassis durability, NVH analysis, and nowadays they are working towards EV like battery and motors. So they build applications, and then the apps are being used by the CE teams and other teams within the MRV for development of various products. Harman just wanted to build a luxury car with a maximum customer experience with their audio systems. So they wanted to design a car around an audio system and use Comsol to find out the perfect location for a speaker to enhance the customer experience. Well, I can go on. So this is another case for a Hyperloop part. A lot of complicated analysis like structural, CFD, acoustics. railways also use Comsol because nowadays they are moving towards electric solar trains, wants to increase the speed of the trains. So RayCam actually you are able to reduce the weight of many structures which supports the electric trains when they pass through the structures. So they were able to optimize them. Another example of wireless charging, they wanted to balance out the thermal and electromagnetic performances. Mercedes-Benz, they use Comsol for corrosion applications. They wanted to find out where the corrosion may occur within a vehicle. And using Comsol, what I'm trying to show here is that it's a multi-physics tool. Electromagnetic, structural, chemical, heat transfer, CFD, everything is done in the same graphical user interface in the same model. But once the model is ready, which is being made by an expert, then the apps can be created and which can be deployed across the teams. And everybody will have an understanding of what a model is doing, how the app is behaving, what kind of results they are getting. So instead of, let us say, validation engineers looking at Excel files, they will now see a model and interact with it. For battery modeling, Comsol can help you finding out in the most suitable cooling mechanism, be it air-cooled, liquid-cooled, filler materials, or a combination of all three of them. It can be used for aging analysis, detailed electrochemical analysis can be performed, or if you have some cycle life data, calendar life data, you can also use that. Thermal runaway, there are up to 10 different events which can lead to thermal runaway, most of them electrochemical, but also some mechanical events. For instance, in a scenario of crash, thermal runaway may occur. So one can predict when and how the thermal runaway may occur in a specific battery pack under various scenarios. And again, the multi-physics aspect, because in a battery you are combining, in Comsol in fact, electrochemistry, structural mechanics, heat transfer, so all of them being done in the same model simultaneously. Again, for motor modeling, you may not be interested in electromagnetics if you are not making motor, but you may be interested in NVH analysis as well as cooling of the motor. So both of things can be handled beautifully in Comsol. We have apps which we can show you. Also for the efficiency map of the motor, torque versus temperature. Fuel cell, another thing with, where we are pretty good. So if you are into fuel cells, you can use Comsol. If you are into fuel cell stack, you can determine the overall efficiency, losses, and the water venting. It's a model of heat sink. It's an application basically where a battery is being cooled. So there are many applications in our model builder and apps basically where you can find out how various apps are being used to cool the battery, strategies to cool the battery. Our users are also in fact using it. I just wanted to show you how a complicated model can be built in Comsol. For instance, there is a vibration coming to the car cabin from the tire, vibration coming from the motor, wind. So all of these can be coupled and the vibration felt by the passenger can be found out in Comsol. And the app can be built which can be used for design, CE, testing, validation, and all the stages whenever it may be needed. EMI-AMC wire harness again. We have a RF product which is very strong in that domain. So a lot of EMI-AMC RF can be done. What I wanted to show you is that Comsol, you can integrate Comsol with most of your CAD tools. If you are using MATLAB, you can do that as well. So it's an intuitive platform. It behaves with your existing tools pretty well, and you can integrate it with solutions that will help you in design, optimization, and finding out the performance of your EVs in the real world scenario. Thanks. Any questions? Let me know.
Thanks, Vineet. And if the audience has any questions, do reach out to Vineet. And thank you. Next, we have Hello Space from Japan, which have visited our community meetup today. I will invite Hello Space team to kindly come here and basically talk about their product.
So today, we came here to introduce new technologies for every electric vehicle. We come up with a new method for electric vehicle, which is using magnetic features. So we are saying magnetic drive system. So initially we made it for e-bicycle. So our smart e-bike doesn't require external charging. So electricity will be generated while you are pedaling without magnetic resistance. So you don't feel heaviness while you're pedaling the e-bike. So this is an executive summary of what we are developing right now. We would like to make superconducting mobility in the future. It doesn't require external charging. But in order to develop it, we need to develop a lot of technologies, like a graphene solid lithium battery, graphene solar system, superconductive generator, and mag drive system. We just finished mag drive system, and those other technologies are under development right now. This is the one. I showed the video. So this is a generator installed in around the pedal. We can install it in the wheel too. So without resistance, it creates the power. Then it will charge the battery, and from battery, electricity is going to the motor. So it's kind of semi-permanent electric assistant system. So it's good for say, emergency generator. It can be worked as emergency generator and battery. So it doesn't depend on the infrastructure to charge. So please try our prototype later. This is on the floor basement, so you can try. You don't feel heaviness while you're creating power. It's the spec of the version 1, which is under development right now in India actually. We came here to find business partners. Actually right now we are working with Toyota Tsusho Next Electrics India to develop the product. It's a spec. So for EcoMode, last forever. Then we would like to make this kind of product. So like easy attachable generator and easy attachable batteries for e-bike. This is the in-wheel type. This is mid-hub type. It's for e-scooter. It's like e-motorbike, e-scooter. It's easy to make it for us. This is the battery we are trying to make. On the surface, we would like to do coating as a graphene solar system. The inside, we would like to install graphene solid state lithium battery. We are developing it in Japan now, and we would like to find the partner, manufacturing partner in India, if possible. Yeah. And also, we are developing this kind of unmanned driving system with IIT Hyderabad right now. So it's a project for the share cycling. You can drop the e-bike anywhere. Then the e-bike will go back to the station automatically. Yeah. Also, we are developing this kind of e-bike station, smart e-bike station, with a Japan Rail group. Japan Rail. It can be like a microgrid base. It can create a lot of electricity and provide electricity to the buildings or stations around. Yeah. And also we are now developing a superconductive type of magnetic system with liquid nitrogen. So by using liquid nitrogen, we can reduce the electric resistance too. So this is a POC. So comparing to the normal temperature, this is minus 200 degrees. The result was we increased the power more than twice. This is the result. This is for wind generator, wind power generator, a superconductive E-type, and also a superconductive EV platform. This is we would like to make this kind of platform and provide technologies to all the manufacturers in the world. And we are developing the complete car too right now. This is a partner called Forefly. It's also a Japanese startup. Actually, we are using Chinese EV van and customize it for Japan. But we want to find Indian EV manufacturer because we don't want to depend on only China. We want to diversify the manufacturing base. That's why I came here. Yeah, so this is our board. We are also research and developing gravity technologies. This is actually Russian startups. They are vehicle. It does not require fuel energy. It's very clean energy. We are also developing this kind of aerobic. And in the future, we will realize no fuel spaceship can last forever, can go to anywhere in space. This is our goal. So thank you very much. This is all. Please try our invite.